Before I begin, all the slides, the sample code, and a screen recording, if it turns out all right, I'll be making it available online. So you can just sit back and enjoy. My name is Michael Moose. I'm going to be talking about unit testing PHP applications. And just a little bit about me before I begin. I've been writing PHP code for about 15 years now. I'm lead developer at the XAM Network. We make gaming better. We make games, or we make sites for popular online games like League of Legends, World of Warcraft, etc. And I'm also a Zen certified PHP engineer and ZF2 certified architect. I'm going to try to go over a lot of things in this talk. Might not have time for everything, but I figured we'd rather have bonus material than finish early. So I'll be doing a brief overview of what unit testing is, help you get started. A lot of test examples, go into testing in isolation, testability, various metrics that you can use while writing tests, and also some tips and tricks. So I like to begin with a definition of sorts of what a unit test is, and for me that boils down to three main points. They're an automated means to verify small portions of a specification. In that sense, it's automated because you don't have to do a whole lot to run your tests once they're written. It's a manual process at first, but as you go, the tests that you've written in the past are able to be executed quickly. Small portions, we're not looking to test the entire end-to-end of filling out a form, submitting it, plopping something in the database, and displaying information back to the user. There are other types of tests that are more appropriate for that. For unit testing, we really look at individual methods of a class and how they interact with all of their collaborators. And a specification, it's just your definition of how things work. If your definition is incorrect, your test will still pass, but the implementation will still not be correct. So essentially, does this unit of code do what it is expected to do? So not that. This sort of thing doesn't scale very well for large applications, especially when you have a lot of changes going through with a lot of developers. You can't possibly go into your browser and test everything, even the things that you didn't expect your recent changes would affect. So to get started, we use PHP Unit. PHP Unit's the de facto standard. There are some other testing libraries out there. I prefer PHP Unit, and it's used pretty much everywhere. Easiest way is installing it through Composer. If you're not familiar with Composer, definitely check out the Composer talk, I believe tomorrow. Very essential tool for PHP development. And I'm going to just dive right into examples. All right, so start off with a simple object. This is a class representing a person that is given a first name and a last name, and we have a single method here to get their full name, which is just a concatenation of the first name and the last name. Pretty simple contrived example, but it's suitable for our purposes. So here we have a test that is going to create a new person and call this getFullName function and just test to make sure that we're getting the same result back that we expect. If I run this,
can you make your font a little bit bigger?
Yes, sorry about that. My apologies. Thanks. There we go. Is that better? Okay. All right, so I ran this test, and I get a fancy green line here telling me that I ran one test where I made one assertion and that test passed. So now, if at any point anybody changes this method or makes any kind of mistake, when I run the test again, then the test is going to fail. It's going to tell me exactly why it failed and what I need to do to go back and fix it. Let me make this larger as well. There we go. Hopefully that helps. All right. Now, let's say that we've got this person, it works great, and now we want to add support for a middle initial. So anybody that has a middle initial, they can include it here on the end, and that's going to be displayed in the full name. Well, that's great. This works. Pass the 3, and it returns the full name. But if we run our existing tests, this ends up breaking because we had our first test that had just the first and last name. And there could be places in our application that are creating a person with just a first and last name, and they would be broken if we were to make this change without updating those areas. If I move on, we can make this parameter optional. So now this original test doesn't break because of the constructor, but it's still broken because the output is incorrect. We have the optional middle initial, but if there's no middle initial, then there's no point in having the extra period and separating it with an additional space. Finally, we add a condition if there's no middle initial, just display the first and last name how we did originally. Otherwise, we include the middle initial and the period, and then at this point, all of our tests pass. So we were able to implement this new feature supporting a middle initial, and we know that anything else in our code base that may have been using the original person with the first and last name is not going to be broken because our test would have picked it up. PHP unit works with a series of assertions that essentially tell PHP unit, I want you to make sure that this input is equal to this output, and if not, display this message. Most of them are going to be formatted in this way. The expected value is what you expect the function to output, and then the actual is going to be what it actually outputs, and then it can display a message. So if I make this incorrect here, and I run the correct test, then it's going to complain and it's going to display the custom message that I had. If the message is optional, if you exclude it, PHP unit will display something that makes sense. In this case, I'm asserting that an array contains a particular value, and it'll tell me, no, this array does not contain the value 4. For most asserts that you have, there's also an assert not. So we'll assert the opposite, in this case, asserting that this array does not contain the number 4. You can test equality or identity. So kind of like an integer 1, 2, 3 compared to string 1, 2, 3. They're equal, but they're not identical. And in many cases, you don't need the expected value either if it's part of the assertion. Here, assert true, assert false, assert file exists. There are a few others. What I like to do at times is use variables in my tests. I have 2 tests here. One is the original first name test, and this one is one with variables. Again, in this case, it's a very small example, but you may have a more complicated test with a lot of setup code. So if you want to go in and you want to change one of the test parameters, I'd have to remember to change it here, and I'd have to remember to change it in my assert same as well. Whereas if you just have a variable, just change the variable, and the change propagates throughout the rest of your test.
Can you compare the 2 person objects?
Yes, you can do. I'll do it right here. Let's do. Foobar. I'll do person 1 and person 2. So if I do an assert same, then it should fail because even though they're the same person, they're not the same object. So they don't reference the same object. Obviously, person 1 would be the same as person 1, but they are the same person. So in the case of when you're comparing objects, I'll go into mocking later. But if you have say a mock database that you're going to have it return a certain object, and you're injecting that object on your own in your test, you can use assert same because you know it's going to be the exact same object. If it's a case where you're running some code that's going to generate something, you will probably want to use assert equals. So you'll know it's the same type of object and has the same properties and such. When in doubt, you can just use assert true. You really could get away with only using assert true, but it's going to make your tests less expressive. I'll show you this example here. If I have foobar and I want to assert that the string ends with bar, if I change this so that the test fails, it's going to tell me that failed asserting that false is true. That's completely useless to me if I run it. I have no way to know really quickly what this is for. I'd have to actually go into my test class and find it and figure out what's broken, whereas if I just use something like assert string ends with, then it'll tell me exactly what it is. I have a string that ended with something that it wasn't supposed to end with. In many cases, you'll find that this code that you would plug into assert true to test your expectation is what PHP unit is already doing behind the scenes. The code here is exactly the same as what I have in the test, so it's just a shortcut. You can see a list of the assertions if you just if you use type hinting in your IDE. Assert, and you'll see that we have a variety of different assertions here. The assert attribute ones are particularly useful if you're testing a class that, let's say you have a class that you're injecting a database or an HTTP client, and you're setting it as a class parameter, but you don't actually have an accessor to get that from outside because you don't need it in your code. You could use a assert attribute, and it will use reflection to check and see if that type of object is correct. I think this is the last basic example. Yes, any questions before I move on? Okay. All right, so that's all well and good, but now we have something a little more complicated. We have this weather service class that has a function to return the temperature in a particular city. To do this, it checks to see if it's available in a cache first so that we don't go and hit the third-party API every single time someone requests the site. And if it's not in the cache, it'll download it, and then it'll set it in the cache. The problem here is that we're using a cache, we're using an external API. In another example, we may be using something like a database or a file system. And these things are actually, they're compared to how fast your test should run, they're slow and they're potentially fragile. When you're running tests, you want to run your test suite on the order of milliseconds, depending on how large it is. For a large test suite of, say, my job, I have about 500-600 tests in my application now, it takes like 6 or 7 seconds to run. If every one of those tests is connecting to a database or connecting to a third-party API, it's going to take a lot longer, and it's going to be more difficult to run those tests between commits. So what we do to avoid this is we don't explicitly test the cache server or the database server or whatever API we're using. We just want to test that our code is doing what it's supposed to be doing with those dependencies. And we do that with mock objects. Mock object is just an object that it behaves a certain way that you define. You create the object, you say what type it's going to be, like say a database type or an HTTP client. Tell it what methods it should expect that the class under test is going to call, what parameters should be included, what values it's going to return, and then you'll use that in your test instead of the real object. So rather than creating a real database, I create this mock that will behave exactly as I've told it to behave, and if it does anything different, the test is going to fail because those expectations were not set, and you'll know that your code is doing something that it's not expected to do. So let's look at our weather service. Same code that we had in this other place, except here's the cache TTL, 900 seconds, so we'll check every 15 minutes or so, and we're injecting a cache and an HTTP client. I'm using Guzzle for this, great library for HTTP client. And here's our test. Before I show you the mock object way to do it, I'm going to show you the wrong way to do it. So I comment that line. And it's going to fail gloriously because I'm not even connected to the internet on this computer, so it's not able to resolve the host. If I were connected to the internet and the host were down, it still wouldn't work. But there's nothing wrong with my code. My code is perfectly fine, but it's just the API that's down. Or if the cache server is down, my test would fail, but my code is still correct. That doesn't help me very much. And even with setting the expectation, if I'm checking against a live API for the temperature, how am I supposed to know what the temperature is ahead of time? How am I going to tell PHP unit what to test? There's no way to know. So what we do is I have this test that's going to do the situation where the temperature is already in the cache. PHP Unit has a built-in mocking library. I'll show you that in this example. There are others that I will go into a little later. We use getMockBuilder and tell that I want a memcached object to expect that the get method is going to be called on it. And then calling getMock will create the mock. And then I set the expectations. So this memcached object should expect one time for the get method to be called with this MD5 hash of the city. That's just so that you get clean keys in the cache. And then it's going to return the value temperature equals whatever I have set the expected temperature to be. In this case, 90, because that's usually the case in Miami. And so instead of creating a new cache like I did up here, I inject this mock cache. And when that test runs, the first one is skipped, so each of these dots or the S represent a test being run. In this case, the second dot was this test, and this ran. If you there's our 90F that came back from the test that we injected. If we change that, we'll get a different result. And then in this case, a little more complicated one. In this case, we don't have the temperature in the cache, so we need to go to the API to get it. Same as before, except in this case, I'm using a mocking library called Mockery. I didn't used to be a great fan of Mockery because I never took the time to really learn how to use it. But I highly recommend you look into it. The documentation is really thorough, and it provides you with a lot of shortcuts and advantages that you don't have with the default PHP Unit mocking library. So in this case, same thing. I create the mock, should receive get once with this cache key, and return null because it's not in the cache this time. And I also should expect the temperature to be set because after we retrieve it from the API, we're going to plug it back into the cache. And then finally, mocking the HTTP client, get once that URL, and I've created a fake guzzle response here that just contains the temperature data in JSON format. And that's it. That accomplishes essentially the same as the PHP Unit mocking library works, just a different way of doing it. Ignore this for now. That's required for Mockery at the end. This is so that it'll verify all the assertions that you have set previously just in case they hadn't been executed. So if I'll, let's say I don't do this part. Let's say I just leave out the get. Sorry, I'll leave out the set. That's what I meant to do. All right. So we get the temperature from the API, but we don't reset it in the cache. It's going to fail because it expected that this should be set in the cache, and it was not. But if I don't include this mclose, it's going to succeed all happily because it didn't check that there were any dangling assertions. There's an easy workaround to this. There's a plugin. I'll show you that in the tips and tricks section if we get that far. Any questions on mocking before I move on? Okay. Yeah.
When I was using Mockery, I couldn't override a private variable.
You have to explicitly tell it. For private you can't just at all. For protected you can. It's a limitation of PHP. You're not. The way that it creates it is it extends the class and adds this functionality to it. So you're not going to be able to do that if they're private because the subclasses are not going to have access to the private data. You can do that for protected though. Yes?
Actually, there is a way to do that, and like using the built-in like the mocking instruments in PHP Unit, and Sebastian Bergman has like an essay on that stuff called testing in private. There is a way to do it, but you should be doing it.
Yeah. The ideal situation is that you don't test the private methods and properties and such directly, but rather you test the public interfaces to them. So that way your tests are not dependent on the internal workings of your class. You only need to know what's available publicly to anybody consuming the application. All right, so I want to talk a little bit about testability. How many of you work on a legacy application that's really difficult to add tests. Probably everybody, or at least in the past, you have. In my experience, I've found that there are. It's really narrowed down to about 5 things that make code really difficult to test. It's objects creating their own dependencies, global, static methods, and singletons, which are kind of the same thing, if you ask me, and classes that just do way too much. So, in terms of objects creating their own dependencies, I've seen code like this before where you have a constructor and you create a database, and this is a database that the class is going to use. Or in many cases, you don't see this much with object-oriented programming, but you do see this in the procedural world that you just call a function and you go ahead and you create the database right there in place. That's basically impossible to test. Well, it's not impossible, it's very difficult to test because you need to be using something called dependency injection instead. It's just a fancy way of saying to pass stuff in as parameters. If I pass in the database into the constructor and set it, then I'm able to mock that in my test before I execute the application code, and then my get post is going to be using this in the first 2 ones over here. In the first one, you could kind of get away with overriding that property using reflection. It's more difficult, and the whole point is to make your code easy to test. But in the bottom one, you're pretty much stuck. It's a local variable created in that scope, and you're not going to be able to override that. And so you're always going to be connecting to a live database if you're testing this method. Global, static methods, and singletons are essentially the same thing, pretty similar. Globals, you're pulling things out of nowhere. The value of this global variable can change between methods. You don't know where things are coming from. Using static methods, you can kind of override static methods. It's tricky and it's complicated, and again, the whole point is to make your code easy to test. And singletons, same thing. If you need only one instance of a class, just create one instance. By doing this, any class that's using this database via the get instance is not going to be able to be mocked either. So just inject them, inject the dependencies. It's really easy. And then classes that do too much. I've found that when you have a class that has a variety of responsibilities, like in this case, this class serves as a renderer for posts. It serves as a data retriever, goes into the database and gets the post information, and serves as a data mapper, converts those rows into post objects that then get used by display posted to display them. There's a lot going on in there, and when you have too much to do, there's really too much to test. If I wanted to test, displaying posts, instead of just saying, here, display these posts that I've created for you, I have to go in and mock the database so that it'll return the posts that I wanted to see when I could instead just pass them in. Or if I want to test getting the post, I have to worry about the data mapper and all that. It's good for classes to just have a single responsibility, one and only one reason to change. So something like this, we would want to separate into a class that's responsible for the rendering, or perhaps a view script, and something for data retrieval and data mapping, such as if you have an ORM or another layer where you do your database stuff. Because if the class has fewer reasons to change, there are fewer reasons for it to break. I'm going to go on into metrics. Questions on testability? No? Okay. So there are 2 main metrics that we can use for when we're unit testing. There's code coverage, is a primary one. And then there's the change risk analysis and predictions, aka CRAP. No, I did not come up with the name. Code coverage measures how much of your code is being executed by a test, and will also show you what tests are executing that code. If you have higher test coverage, you usually have a lower risk of changing, or a lower risk of breaking something if you change your code. But that's not always the case. You can have 100% test coverage and have all sorts of problems. So it's a guideline, it's a good goal to strive toward, but you really want to look into going beyond that. Right, so code coverage. We're going to run test code coverage. Let me show you the class first. Simple calculator, divides 2 numbers, nothing fancy here. test, divide 5 by 2 and get 2.5. Really simple. Alright. So there, it's this test ran a little slower. It took 166 milliseconds when we're used to seeing runtimes a lot small, and that's because it takes a little longer to use Xdebug to gather all the code coverage reporting stuff and generate the code. All right, so we see here that since I have that test that executes this one line of code, I have 100% code coverage in this calculator. And if I mouse over that line that's covered, it'll tell me that I have this one test, and I can always go back and look at these tests. If I find something that's broken or not broken, I can see what tests are covering it. So now we have 100% test coverage in this class, but there are still all sorts of problems with it. Let's say instead let's say we want to divide 5 by 0. We know we can't divide by 0. I run it, bam, division by 0, I have a failed test, but I have 100% test coverage. So 100% test coverage doesn't mean that you've covered every possible scenario. It just means that every line of code is being executed by something. Don't think only about that. Think about edge cases. What sort of parameters can somebody pass into this function to mess things up? What different execution paths can your code take through a function? If you have several if statements or some loops, well, I could enter this if statement and not this one. Look for a path there and test that path. If it's a functionality that's critical to your application, it should have a test. So now, let's say we want to fix that. So we add a check. We check for the denominator, and if there's a problem, we throw an exception that says that we can't divide by 0. Run that, great, test passes, but we have less than 100% code coverage. We've added something that fixed something, so this is an indication our code is telling us, hey, you have this functionality that you've added that is clearly important because you added it, you should cover it with a test, so that if somebody removes it or if somebody changes it, you'll know about it and you'll avoid breaking any sort of backwards compatibility. So here I add a test. These are test annotations. There are a few different ones that you can use. You can find those in the PHP manual that I linked to a few slides ago. In this case, I'm telling it that I expect this method to throw an exception, and I'm telling it what I expect that exception to be. And when I run it, since I am going to trigger an exception for trying to divide by 0, that test passes, and I'm back up to 100% code coverage. Other than dividing by 0, I don't really see anything that can go terribly wrong here. So in this case, I would be comfortable continuing on with the rest of my work. Okay. Code coverage questions? No? Okay. All right. Change risk analysis and predictions, aka CRAP. Design, analyze, and predict the amount of effort, pain, and time required to maintain an existing body of code. Basically telling you how much trouble you're going to go through if you try to change something in your application. The link at the bottom is from the blog of the person who came up with this. It's a very good read. I recommend checking it out if you're interested in this metric. Warning, math coming. That's the formula for it. You don't need to know the formula, but it is a lot simpler than it looks. Basically, you have the M represents a method, in this case the method that we're testing. Comp is the cyclomatic complexity. That's just how many decisions are made in it. If you have some if statements, well, there are decisions. If there are no decisions being made, if you're just returning a value or something, complexity is 1. And COV is the method's code coverage. So if we look at, if coverage is 100%, 1 minus 1 by 100, that becomes 1. And then the complexity of the method is just going to be the CRAP square of the method is just going to be the complexity squared plus the complexity. So if I have let's say I have a method that has a complexity of 1 because it's just returning a single value. 1 squared plus 1, it's 2. Crap score is 2. I have a method with a lot of complexity, a lot of if statements, a lot of loops, things like that, and it has 0 coverage, then, sorry, this in the previous example, this actually becomes 0. This is 100 divided by 100, 1, 1 minus 1, 0. So if you have 100% test coverage in a method, the crap score is just equal to the complexity. So method with no decisions being made and 100% test coverage has a crap score of 1. For something more complicated, if you don't have any coverage, then the complexity squares and it ends up with a higher crap score. Simplified formula: if your application is complex and you have few tests, crap. So you want to try to reduce complexity and try to increase your tests. So this example is taken from this blog post below. It goes into a little bit more detail than I'm going to go into the talk, so check it out. We have, can everybody see that? Is it a little difficult to see? No. All right. I'll try to walk through it. So this is a crap class that lists cities. You pass it a state, and it's going to output a list of cities. And it has an if statement for every one of these states. There's Nebraska, Iowa, Florida, etc. And it prints the name of the cities. And if there's a state that it's not aware of, it's going to throw an exception. And we have this, and we haven't written any tests for it. So it has a crap score of 42. If you remember the formula on the previous page, the 0 code coverage means you end up with the complexity squared plus complexity. So 6 times 6 is 36, plus 6 is 42. So this method has a crap score of 42. There's no hard and fast rule that your crap score must be less than X in order for your code to be good. It's a guideline. If you see a lot of methods in your application that are okay with their crap score, maybe in single digits, and you see something here that's a 42, that's an indication that you need to do something about this. Now, if we write some tests for this method, we're only covering about half of it. But that's dropped the crap score from 42 to 11.62. Means it's a little less risky to change this method. If we go in and we change something, there's a good chance that one of our tests will pick up an issue with it. If we increase it to 100% coverage, it goes all the way down to 6, and that's the minimum complexity that this particular method can have because of the number of decisions being made in it. So at 6, we know that we really can't do anything else to reduce the score just by increasing the tests. But that doesn't mean that the code is any less bad. I haven't changed the code at all. I've just added tests for it to reduce the crap score. But there's still issues with the code. There's a lot of risk involved in changing it. So instead, let's make the code less complex. So this list cities method that we had before that had several if statements to check the states, now it's just a single if statement. It's going to check and see if the state that we are looking for exists in this array, and if so, it'll echo out the list of cities. Otherwise, it'll throw an exception. So now we're down to only 2 decision points in this method. And running those same tests, crap scores 2. That's the bare minimum. We really can't go any lower than that for this specific method because it's doing a test. This version even has the same crap score as the previous version with 100% coverage. So if I were to remove all the tests that are written for this, the crap score would be 6. So it's a trade-off between maintainability and so the idea here is to make our tests to make our code less risky to change. So I like to look at testing as a way to help me write better code. If I find that a particular method or class is really difficult to test, that's an indication to me that I need to go back in and change something in my code. Maybe I'm not injecting dependencies where I need to be. Maybe I have a class that's doing way too many things. And if the crap score is really high, it's another thing. You can see that typically methods that are really long will have high crap scores. Methods that do a whole lot of logic back and forth are going to have high crap scores. These are metrics that you can use to improve the quality of your code. So listen to them and do your best. It's not a foolproof way to do things. There's not really any right way to do it. It's just a guideline. All right, and so we did make it to tips and tricks. So I'm gonna try to run through this pretty quickly because we're kind of low on time. Let's start with the PHP unit.xml configuration file. You saw me on the command line typing a whole bunch of stuff out. I was doing that so that you can all see how it works. But in a real application, you would have a PHP unit.xml file. And this is just a configuration file for PHP unit. Bootstrap, I'm telling it that before you run any tests, load the vendor autoload. That's the file that Composer generates to autoload all my classes. I tell it that I want the pretty red and green colors when my tests pass or fail. And then here I'm telling it what I want to cover with code coverage. There's a filter. So initially exclude everything and then only include items in my SRC directory for test coverage. If you noticed when I generated code coverage the first time, you saw the vendor directory ended up with being recorded for coverage. It's because I just ran it from the command line. If I were to run this again, and it would use my configuration file, then it's only going to oh, clearly I missed something. I'll fix that when I post the slides and the sample code. But you don't want the vendor stuff to be recorded in your code coverage metrics. You only care about your code, so you do that here. Let's see. Logging. This is where I define code coverage, so I don't have to type -- code HTML, etc. You can define high bound and low bound. So when you see down here, it's saying that the high coverage is 100% and medium is 99 to 100. If you're not quite that draconian with your testing practices, you could reduce medium to say 50 to 80% is medium, and anything higher than 80 is considered high. Depends on your organization and what it is you're doing with your app. So okay, with Mockery, I mentioned earlier there was a trick to avoid having to do that mclose, and that's using this listener. This comes with Mockery. And all this is going to do when this is plugged in, it's going to automatically execute that mclose after your tests finish. So if I go back into the weather service, you see that I don't have the mclose anymore, and my tests still pass. If I were to remove the listener, well, if I remove the listener and I remove the set like I did before. Did I skip that? Let me make sure I'm running the right. Oh. Yeah. I thought that removing it would make it better. All right. I'll fix that too. Sorry. All right. Okay. Common prep code, setup and teardown. Let me show you that. So in our original weather service, we have a lot of stuff that we need to do to get our tests set up. Here I have to create the memcache instance and create the guzzle mock and pass those in. If you have a lot of, in this case it's just one method, but if you have a larger class that has several methods that all have the same class dependencies, you're going to be rewriting that code a lot. Good way to avoid that is to use a setup and teardown method. So this setup and teardown, setup is going to be run before every single test that you execute, and teardown is going to be run after every single test. What I do here is I like to define a class variable on the test to represent the mocked cache and HTTP client and also the service that I'm actually testing. And so I create it here. I create the mock because I know I'm going to need the mocks and I know I'm going to need the weather service. And then in my tests, I can just go ahead and use them because they're already set. And I just define my expectations on the mock and I go ahead. There's also a setup before and tear down after class. These are going to run once before and once after your, each test class. If I run that, you'll see welcome to the weather service test, and you're now leaving the weather service test. That's completely useless, but it's an example of what this does. Depending on your use case, you may find a use for this, but it's there if you need it. In many cases, though, you will have a great advantage using the setup and teardown methods. Let's see, let's talk about data providers. Data providers are another shortcut. Let's take a sample class. Let's say I have a string class that, pretty simple, created with some text, and then I reverse it. Could have used string reverse, but this is more fun. So this is our reverse method. And I don't just want to test that with one string. Maybe I want to test it with a few different strings. Maybe I want to add, see what happens if I pass it a null or if I do something weird. But to do that, I would have to write the same test over and over and over again. You don't have to do that. You can use a data provider. To do that, use the data provider annotation and give it the name of a method. And that method will be used to pass parameters into your test. So right up here, the first parameter in the list ends up in the first parameter in the test. Second ends up as a second, and then I can go ahead and I can run this, and I'm able to test it with all these different combinations. If I let's say I add one that has a breakage, PHP unit is going to tell me which one broke with data set number 2. So I can go back to my test and say, okay, well here's the data set at array index 2. I know this is broken, so let's see, is the test input broken or is the application broken? In this case, it's a test input, so I can fix it. Data provider is very handy. Mocking PDO. Anybody use PDO for database stuff? You ever tried mocking PDO? All right, let me show you what happens if you haven't. All right, so I want a PDO. I don't want to call the original constructor. Give me a PDO. Boom. Can't serialize or unserialize PDO instances. What do you do now? It's a very common problem. Fortunately, there are a couple solutions. One is to use a stub helper. So I've got a PDO test helper. This is just a class that extends PDO and disables the original constructor. So now when I try to mock PDO, instead of trying to mock PDO, I mock my test helper, which is, the application's not going to know the difference. It's just expecting a PDO object, and this is a PDO object. In this case, run it. And actually, I'm just going to run that specific test class, otherwise we're going to be, there we go. And then in this case it works. I have my mock PDO instance. Great. There's an even easier way, and that's just to use Mockery. Mockery has this built in. So let me see if I can find it. I can show you guys how it works. It's pretty handy. Here, so yeah, so Mockery is going to try to create that PDO, and PHP is going to throw an exception because you're not allowed to mock it. And then what it's going to do is it's going to create a class on the fly for you without that constructor there. So it's really nifty. You can avoid having to create stubs for all of your unmockable classes. There are a whole bunch of different classes in the core PHP that you can't unserialize, and that's how mocks are created, using unserialization. So this is pretty handy. And mocking global functions. How many people have global functions in their applications, like calling a microtime and file put contents, things like that? You don't want to necessarily call those because it can make your code difficult to test. For example, microtime. Say I have a class that just returns the microtime. Whenever I run this, that is always going to fail. It's always going to fail because between the first time I call microtime and the second time I call microtime is going to change. There's not going to be any way for me to test this. So one way to fix that is to mock microtime. You're not exactly mocking it. It's a bit of a trick. What I've done here is I've defined a microtime function inside of the namespace of the class that I'm testing. So in this class, when microtime gets called, it's not going to call the global PHP microtime. It's going to call the microtime that is under this namespace. Oops. So in this case, it passes. If I needed to actually call the global one, leading slash will call the global one. And then it's going to fail just like it was failing before. That's great if you have if there's not a whole lot going on in your test or a whole lot going on in that namespace. But there are some cases where you may have different classes in your namespace, in that same namespace that is using this global function. So if you mock it in one, you're not going to be able to remock it in the other because you're redeclaring the same function. I discovered a cool PHP extension recently called UOPS, and that really does the trick here. It lets you, you can install this using Peckle. It's really simple to use. I can create a backup of the real microtime function, which I restore later after I'm done doing whatever I need to do with it. And then here I just pass it my own definition of microtime. So for this test and only this test, microtime is going to return 1, 2, 3, 4, 5. Once I've restored microtime, any other test that calls microtime is going to return the real microtime, unless I override it again. This is super handy because you're going to have that issue where different classes in your namespace will need to use that same function. You can also use this to replace functions in classes, in static methods. What I told you earlier about how static methods are difficult to test. They're difficult to test, but they're not impossible because you could just do something like this. You can actually go in and redefine what that method is going to do. But it's more difficult. It would be a lot easier if I had an object that is responsible for timing stuff and I could just mock that and tell it what to return. You can read this blog post on the bottom for more details on UOPS. And that's it for examples and the bulk of the material. Did that already? Some good books on testing. Test-Driven Development by Kent Beck. That's the first testing book that I read. It really goes into a lot of detail on test-driven development, which is essentially writing the tests before you write the actual code that implements what those tests are specifying. And it's a great way to just go through and not have to worry about going back to the browser. Oh, does this work? Does this work? No, you just write the test as you go, and you will be getting that feedback from your tests. Growing Object-Oriented Software Guided by Tests. That's another good book. These guys go through and they build a non-trivial application guided by tests. These first two books are in Java. The first one, the syntax is really simple. It's easy to understand even if you don't have a Java background. Second one is a little more complicated. And then the third book is the Grumpy Programmer's PHP Unit Cookbook. He goes into a lot more detail of a lot of the stuff that I covered today. In these chapters, I've read that book, and even after several years of testing, I learned some new things too. So, just closing thought I want to leave you with. I've been in a lot of places where either somebody changes something that breaks production, or I change something that breaks production because I didn't expect that my change had anything to do with the thing that broke. Don't be that developer. Write tests. The tests are going to remember that this has to do with that, and it'll save you a lot of heartache. So that's the talk. Please rate it. If you liked it, tell me what you liked so I can keep doing it. If you didn't, tell me so that I know. And I'll be posting the slides and the sample code to the GitHub link within the next hour or so. And when I've had a chance to check on the recording, if that came out well, I'll upload it and I'll share a link. So I think we have a little bit of time for questions. If anybody, yes.
Is it necessary to test for exceptions a lot, or?
It's necessary in the sense that if you have something that's going to throw an exception, you want to make sure that that exception gets thrown in those cases. If it's like if it's an exception that you don't plan to handle, like let's say you're using let's say you're using PDO and something goes wrong and PDO is going to throw an exception. If for some reason you don't want to handle that exception, you don't really have to test that it's thrown. But if you are going to handle it, then you want to make sure that your code is doing that.
And questions. Do you have any resources that you can point us for PHP with Selenium?
I've seen that you can write tests for Selenium using it. I don't really do the front end Selenium type stuff. I'm more in the unit testing area of it. But Google has tons of results for that. Sorry.
The question, testing or not testing getters and setters?
So with getters and setters, a lot of people say, why am I going to test getters and setters? They're so simple. Well, number one, if they're so simple, just test them. They're quick to test. Number two, if you have getters and setters in your application, something else in your application is using them, so you don't have to explicitly write a test, get, and set. You can just test. You can just have the other part of your application that is using those getters and setters get you that test coverage implicitly. Does that make sense? Okay.
Can you give an example for like advantages of mockery, explicit advantages of mockery, apart from this construction thing you did with video, other stuff that makes mockery like more useful than the built-in?
Off the top of my head, no. If you want to come by after, and I'll show you a few examples. I'll have to connect to the internet to hop onto the documentation and show you a few links. Anyone else? Yes.
Why didn't you plug your QB mocker repo?
Because it's not done. I have a repository for mocking doctrine query builders. That it's kind of a pain to do otherwise, but it's not done. I don't know if I'll ever finish it. So. It's called. If you look under my GitHub, it's I believe it's doctrine-QB mocker. I have a few examples in there. For the basic stuff, like the basic ORM stuff and the basic ODM stuff, it works. There are a few methods that I say are not supported because I haven't gone through the effort of looking and making sure they work, but like 80% of the cases, save yourself a lot of code. Sorry. What? Oh. Sorry, can you repeat the first part? Oh, for debugging. For debugging, usually it's breakpoint and an exit. I don't usually use the debugger. The nice thing about tests is that if your code is small and compact enough, you can run the test and identify where things are wrong without having to go into the full-blown debugger. If I'm in a case where maybe the thing that I mocked is not returning the thing that I expect, I'll go into the application code and I'll do like echo get class on the database just to make sure that my mock is there and not a real database. Maybe a var dump or something like that. Maybe I'll just right after mocking it, I'll call the method myself inside of the test and just echo the output and exit, just to work around with that. As you make progress, you find yourself doing that less and less. But when all else fails, the var dump and die are your friends. Anyone else?